Good day, guys. For today's video, I'm going to discuss about reverse effective force. So, we try to understand one of the important principle of dynamics. The reverse effective force is also known as the D'Alembert's principle, which is an alternative form of Newton's second law of motion. D'Alembert's principle states that when a body experiences acceleration, there exists an equal and opposite force called the reverse effective force. The reverse effective force is equal to the product of the mass and acceleration of the body or object.
The principle reduces a problem in dynamics to a problem in statics. It can be used to simplify the force and stress analysis of machine components because it's easier to determine unknown forces on bodies in equilibrium than on moving bodies. The formula of reverse effective force, so REF, equals to F equals to M times A. So M is equals to weight over G. So reverse effective force is equals to weight over G times A, where F equals to force in Newton. Then M is equals to mass in kilograms. Then A equals to acceleration in meter per second squared. Then W equals to weight in Newton. Then G is equals to gravitational acceleration. It is equals to 9.81 meter per second squared. Note that 1 kilogram is equals to 9.81 Newton. If the imaginary force, called the reverse effective force, is applied to the body equal, parallel, and collinear with the effective force, then the body will be in static equilibrium. So let's have some sample problem. First sample problem is determining the force P that will give the body an acceleration of 1.8 meter per second squared. The coefficient of kinetic friction is 0.2. A block has a weight of 1,500 Newton and a force P that is inclined and have components that is 3, 4, 5. Then the acceleration is going to right so that the REF is going to left because it is opposite. It is always opposite to a motion that is acceleration. So the frictional force is along the way to the REF. Then we have a vertical forces na normal force that is upward. Then to find the normal force, we add the all vertical forces. So summation of Fy equals to 0. 0 equals to, so we have a Newton that is downward, so negative 1,500, and the Newton that is upward, it is positive N. Then this component P is, we have a vertical that is 3 over 5, so plus P 3 over 5. So the normal force is equals to 1,500 minus force P times components of 3 over 5. So that we have a n, so the formula of frictional force is F equals to mu over mu times n. So F equals, so we have a given that is a coefficient of kinetic friction of 0.20. So we have n, so substitute the n of 1,500 minus P times 3 over 5. So we have to distribute the, so 0.20 times 1,500, so equals to 300. Then the 0.20, let's distribute the force P, so negative 1,500 times 3 over 5 equals to 900. Oh, I know. 0.20 times 3 over 5 equals to 0.12 P. So we have a frictional force. Then to solve the P, we have to add horizontal force. So summation of Fx equals to 0. So 0 equals to x is, the REF is going to the left, so it is negative. Negative weight times acceleration over gravity plus 4 over 5 P, then minus the frictional force is going to left, so negative 300 times minus 0.12 P, then 0 equals, substitute the weight, negative 1,500, then the acceleration that given is 1.8 over, the gravity is 9.81 plus 4 over 5 P minus 300 plus 0.12 P. So let's calculate. 0. So the forces P is equals to 625.25 Newton. So this is the answer.
Second example. Two blocks A and B are released from rest on a 30 degrees incline when they are 15 apart. The coefficient of friction under the upper block A is 0.20, and under the lower block B is 0.40. So first, compute the acceleration of A, then second, compute the acceleration of block B, then third, compute the elapsed time until the block touch.
So let's draw the figure. So blocks A and B are released from rest on a 30 incline. So 30 incline. So This is block A, then block B. So they are 15 apart. 15 meters apart. Then it will released from rest, so they're going down. It's A, B. So how much their distance from rest then released? S. So we have the given value. So given, the given is the coefficient fraction of block A is equals to 0.20. Then the coefficient of fraction block B is equals to 0.40. So first, we need to compute the acceleration of block A. Solution. So we need to find the acceleration of block A. First, we have to solve the block A. So block A has an inclined weight. Then we have a weight, so we have then a normal force. Then the motion, so the acceleration is going down, so that the acceleration is going down to the right. As all we know, the acceleration of the motion is always opposite to the REF. So the REF is going up. W for A, W times A over G. So the friction is along the way of REF. So the weight is inclined. We need a components of X and Y forces. So this is W sine 30 degrees and Y component is W cosine 30 degrees. Then first, we need to solve the normal force. So we get that we need to add all the vertical forces. So summation of Fy equals to 0. 0 equals to, so the weight is going down, so it is negative W cosine 30 degrees. Then the normal force is going up, so it's positive. So N equals to cosine 30 equals to 0.866 W. Then next is we have a friction. So F equals to mu times N. So we have a given that mu of coefficient of fraction of block A is 0.2. So let's substitute. F equals to 0.20. So we have a N. So let's substitute the N. 0.866 W. Let's calculate. So F
equals to 0.1732. Then next is to find the acceleration of block A, we need to sum all of the forces of horizontal. So summation of Fx equals to 0. 0 equals to, so the horizontal forces of components and weight is going to the right, so it's positive. W sine 30 degrees. Then the RAF is going to the left, it is negative. So weight times acceleration over, so the gravity is equal to 9.81. Then the friction is going to the left also, so it is negative. So this is W, 0.1732 W. So if we transposed it, the weight or W is cancelled, so it will cancel, so that we can compute the acceleration of block A. Let's calculate. So the answer is 3.21 meter per second squared. So this is the answer. So the acceleration of block A. Then next is we need to compute the acceleration of block B. So we need also to draw to find the all forces of block B. So a block has a weight and inclined, so they have a component of x and y axis. So W sine 30 degrees, then in y W cosine 30 degrees. So it is also, the motion is going down, so the acceleration is going down to the right, so acceleration, the REF also opposite, so our REF always opposite to the motion, so the motion is acceleration, so it opposite W over G. So we have a normal force, then friction. To solve also the acceleration of block B, we need to find the normal force. So substitute, so let's sum all the vertical forces. So summation of Fy equals to 0. 0 equals to, so then normal force is going up, so it is positive. Then the y component of weight is negative because it's going down. W cosine of 30 degrees. Then
n equals to w cosine of 30 degrees. And we have in a second to find the fraction. So fraction equals to u times n. So we have a given that is 0.40 of coefficient of fraction. So equals to substitute the 0.40, then n w cosine 30 degrees. Then we calculate cosine of 30. So it is 0.346 W. Then to compute the acceleration, we need all horizontal forces because it is a horizontal forces to find the acceleration. So summation of fx equals to 0. 0 equals to, so it is negative because it going to the left, so negative w a over, so the gravity equals to 9.81. Then diffraction is also going to the left, also negative, so 0.346 w. Then the horizontal components of weight is positive, so w sine 30 degrees. Then if we transpose it, it will also cancel the weight. So acceleration, let's calculate, was negative of x over 9.81 minus 0.346 plus sine 30. Shift solve. So the answer is 1.51 meter per second. So the third is we compute the elapsed time until the block touch. So the distance of S. So we have 15 meters apart of blocks A and B, then plus S. It is equals to distance traveled by A. As we all know, we have the formula of S equals to distance equals to initial velocity times time plus 1/2 at squared. So S equals to the, because the block is from rest, so the initial velocity is 0. So if we times it 2 times, it also 0. So plus 1/2. We have an acceleration of 1.51 times time squared. So S S equals to 1/2 times 1.51. S equals to 0.755 t squared. Then we have this, so substitute the S. So 15 plus 0.755 t squared equals to the 1/2 of acceleration of 3.21 in the block A, then t squared. So let's compute the time, the block, the touch. T equals to 15 plus 0.755 for x squared, for equals 1/2 times 3.21, then of x squared. Step solve. So the answer, so the time that elapsed until the block touch is 4.2 seconds. So this is the answer.
Last example, an elevator weighing 15 kilonewtons starts from rest and acquires an upward velocity of 3 meters per second. In a distance of 6 meters, if the acceleration is constant, what is the tension in the cable?
An elevator weighing 15 kilonewtons. So elevator weighs 15 kilonewton. Then it requires an upward velocity, so the tension is going upward. Because it's going upward, then their EF is down because it's always opposite of the motion. WA over G. Then they are given that velocity is equals to 3 meters per second. Then the distance equals to 6 meters. As we all know, we use the formula of rectilinear motion to find the acceleration. So final velocity squared equals to initial velocity squared plus 2as. Then we have a final velocity that 3 meters per second, because the elevator is start from rest, so it is 3 squared equals to, so the initial velocity is 0 plus 2, then a have a distance that is 6. To find the acceleration, let's compute 3 squared 0 plus 2 x 6. So the acceleration is equals to 0.75 meter per second squared. To find the tension, it is all vertical forces, so need to sum all of the vertical forces. So summation of Fy equals to 0. So 0 equals to, the tension is going upward, so it's positive. Then the weight is negative because it's downward. Then also the RAF, that weight over T. That is 15. Substitute the weight, that is 15. Then acceleration 0.75 over the gravity of 9.81. So let's compute the tension. 15, 0.75, 51. Shift solve. So the tension is equals to 16.15 kilonewton.
So that the reverse effective force simplifies the analysis of rigid body motion by converting a dynamic problem into a quasi-static one. This approach is widely used in engineering and physics to study systems under motion. It emphasizes that the dynamic effect of acceleration and rotational inertia can be represented as the fictitious forces aiding in clearer visualization and problem solving. And that's all, guys. I hope you learned something about my video report. And thanks for watching.